Theory of relativity. 2. Faster than light motion. Giant V. Nalaikar. Inter-University Center for Astronomy and Astrophysics. Post Bag 4, Pune 411007. Abstract. This talk describes the notion of tachyons in special theory of relativity. It argues that, despite the limit placed on the speed of material particles by the theory of relativity, it is possible to imagine a class of particles which always travel faster than light. Simple, dynamical concepts like energy and momentum are defined for such particles, and causality problems arising from their presence are discussed. A causality paradox is presented at the end. Introduction. Let me begin with a limerick by Reginald Buller that became quite well known in the early days of relativity. It was first published in the British magazine Punch on December 19, 1923. There was a young lady named Miss Bright, whose speed was far faster than light. She set out one day, in a relative way, and returned on the previous night. The somewhat strange future in store for Miss Bright was speculated upon because the special theory of relativity appeared to place a speed limit on the speed with which any material, object or a physical interaction, or indeed information per se can travel. The limerick voices the questions that many people, including physicists, asked when they were confronted with the bewildering rules about space-time transformations between moving observers. In particular, we may phrase those questions as follows. Does special relativity forbid faster than light motion? Does such a motion lead to violation of causality? Could we imagine a universe in which some particles traveling faster than light do exist? In this lecture, I will try to answer these questions within the framework of the special theory of relativity. These basic ideas were first discussed by George Sudarshan and his colleagues in 1962. 3 kinds of particles. Indeed, 3 kinds of trajectories can be identified within the framework of special relativity. Given the key role that the speed of light c plays in it, I will use the time coordinate as t in the space coordinates as the triplet r equals x, y, z. Light travels along null trajectories. This means that a particle traveling with